All right, class, in this video, we want to cover the basics of working with roots. Specifically, we're going to look at square roots and cubed roots. Now, when you think about a square root, this is how you would see it written. And it's interesting, we never write it, but with the square root, there's always a 2 right here. But we don't write that. We assume that that is a 2. You'll see it written other ways in just a moment. You might see a 3 there. We call that a cubed root. You might see a 4 or a 5 or a 6 there. Now, we're not going to be dealing with any 4, 5s or 6s, but we will be dealing with square roots and cubed roots. So let's look at a square root real quick. I want you to look at this drawing right here. This is a way that I feel helps to make sense of what's going on when we're dealing with square roots, often heard as perfect squares. Every one that I have listed here, square root of 25, square root of 64, square root of 144, and the square root of negative 16. Well, let's come back to this one in just a moment, actually. But these first 3 are all what we call perfect squares. In fact, you know what? Let me just go ahead and do this. What is the square root of 25? Well, it's 5. Well, now how do I know that? What I'm saying with the perfect square is, what is 5 times 5? Well, it's 25. So this 5, we call it a factor. In this case, we're going to call it a root. Now let's come back over here. Notice that I have drawn somewhat of a square, and I've said that a side length is 4 centimeters. Now, you know the formula for area. The formula for area of a square is side squared. So in this case, if I have a side length of 4 centimeters, then I know that it's 4 centimeters squared, which is going to be 16 centimeters squared. Now, to apply our rules of exponents, we know our power of power properties. That's going to be 4 squared times centimeters. Now, that's a 1 exponent in front of both of those, correct? So that would be a 2. So that's going to be 16 centimeters squared. So what if we went backwards? What if I just said, well, what's the square root of 16? What is this? Well, it's going to be whatever number can be multiplied by itself to give you that 16, which in this case is 4. And there's some memory work here, and I'll come to that in just a moment, but I hope you can see that what does this 4 represent? It's not something that's mystical. 16 is at what we call a perfect square, meaning that there's a number that can be multiplied by itself. We're not talking about, say, like 15 is not a perfect square because it would be 3 and 5. Well, those are 2 different factors, 2 different roots, if you will. We're looking for the number that can be multiplied by itself to give me the number under the radical. Now, what in the world's a radical? This thing right here, all right? That's the radical. This would be the radicand. Okay, I'm not too much worried about the terminology, but we're looking for this number right here. If it's a perfect square, then there's a number that can be multiplied by itself to give me that number. All right, so let's stop and think about it. 64. This is where your multiplication facts are so important. I know we live in a world that says memory is horrible, blah, blah, blah. Okay, that's fine and dandy, but I'm just here to tell you. Learn your multiplication facts, all right? Learn your multiplication facts. It will make your math life easier so that when I see the square root of 64, I know immediately, oh, well, 8 times 8 is 64. So the square root of 64, that number that can be multiplied by itself to give me 64 is 8. And I know that the square root of 144 is 12 because I know that 12 times 12 is equal to 144. Now we come to this one, and the temptation is to say, oh, well, that must be negative 4. Well, no, that's a does not equal sign. That is not true, okay? Because think about it. What's negative 4 squared? That's positive 16. I'm going to write the positive there to hopefully make that make sense. Negative 4 squared is a positive 16, not negative 16. We would call this, and we'll deal with this more later, not in this class, but in future math, but this is not a real number, okay? Not a real number. So when you see that, that's the kind of answer you're going to put down. Let's go a little bit further. And this is what I was referring to a moment ago. You need to learn your perfect squares. And this is a simple way to do it. I know that 2 squared, 3 squared, 4 squared, 5 squared. So just pretend a squared is all there. That's going to be 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. 6 squared is 36. 7 squared is 49. 8 squared is 64. 9 squared is 81. 10 squared is 100. 11 squared is 121. 12 squared is 144. 13 squared is 169. 14 squared is 196. And 15 squared is 225. I plead with you to try to put these to memory. Okay, it's going to make your math life a lot easier so that when you see in a problem the square root of 100, you know automatically that that's 10. Or the square root of 169 is 13. Or the square root of 225 is 15. These really aren't that hard to learn. It goes back to your multiplication facts. If you've already got a firm grasp of your multiplication facts, then these numbers should roll off pretty quickly. You should be able to learn them relatively easily. But again, can't emphasize enough, learn these cold, right? Not where you have to think about it for 45 seconds, where you just know them. I promise you, makes your math life easier. Let's look at cube roots briefly. This is just a little bit different. In the last time we were dealing with area, but this time we're dealing with volume because we know if it's a cube, right? Now it's a cube. All sides are the same. That means we're going to have, if this is S, then that's going to be S as well, as is the height. And so the volume is S cubed. And so it's a number that could be multiplied by itself 3 times. So what's the cube root of 8? Well, these are a little trickier. This is going to be 2. Why? Because 2 times 2 times 2 is equal to 8. Now think about that. 2 times 2 is 4. Times 2, that's 8. So the cubed root of 8, and that's how we would read that, the cubed root of 8 is 2. The cubed root of 27, that's going to be 3. Why? Because 3 times 3 times 3 is equal to 27. 3 times 3 is 9, times 3 is 27. So there's a lot more examples from both of these that we will need to work. We're going to do some math operations with them in the coming videos. But for now, just review this video and review the concepts. A square root, a number that can be multiplied, the root of a number, if it's a perfect square, a number that can be multiplied by itself to give you that number under the radical. A cubed root is something, you're dealing with volume in this case, it's a number that can be multiplied by itself 3 times. All right, so review this video, send me any questions you've got.